My name is Axel Rauschmayer, and down here you can see the URL of the slides, so you can download those if you want to. And the URL is not just here, it's at the bottom of every slide down here, so you can't miss it. What will you learn if you make it through to the end of this talk? First, let's look at the snippet. And I'm guessing that most of you have written similar code. And it's ugly. Can we do better? Yes, we can. And in this talk, I'm going to look at a library for ECMAScript 5 that is going to be purely object-based. There are not going to be any functions, and that will make things very pretty. And we're also going to look at ECMAScript 6 that brings a lot of very cool goodies with it. So you have classes, and you have even more. Let's first take a very quick look at the JavaScript inheritance basics. And you should already know those basics, but it never harms to take another look. In class-based languages, you have two relationships. You have the instanceof relationship between classes and instances, and you have the subclass of relationship between classes. And JavaScript makes do with only one relationship and with only objects. So you only have the has-prototype relationship, and that relationship is always between two objects. So this is what it looks like if you use a constructor to create an instance. You get this structure that's depicted here. You have a person, and a person has been created by the constructor person. The constructor points to its prototype, and the prototype, by default, points back to its constructor. And then you have the has-prototype relationship between the instance and the prototype. Things get more tricky as soon as you use subtyping. Then you have a lot more wiring. You have a relatively feeble relationship between the constructor and the superconstructor. But you especially have a has-prototype relationship between the prototypes, which is interesting. And obviously, again, you have the instance. And thanks to this has-prototype relationship, employee prototype gets all the methods from person.prototype, and thus you have the typical subtyping thing. Next, object exemplars. That's the library I alluded to at the beginning. JavaScript has several kinds of object factories. Two examples are you can produce an instance via a function. And those functions are, there's other possibilities. Those functions are usually the constructors. Other than that, you have objects, and you can use those and object create to produce an instance too. But then the question arises, how do you call all of that? What's the common word for what's going on? What's a good word for object factory? And Alan Webs-Brock, one of the TC39 people, he suggested the term exemplar. And if you use that term, then you can call constructors function exemplars, and whatever is going on here, you can call that object exemplars. So let's look at two examples. This is the almost canonical example of a person. You have the constructor function, and you have the prototype. And to create an instance, let's call the instance Joe. And this is kind of, well, wrong name, so should be called Joe, but it doesn't matter, inconsistent data. If you create an instance, then you use the new operator. And that's like the standard way of doing it. But you can also create the exact same instance by just using an object. If you use object create, you create a fresh object whose prototype is person.prototype. Then you have Joe, who sometimes cross-dresses. And then to instantiate, to fill that with data, you invoke the constructor, but you do so as a method. And then what you end up with, you have, like the instance Joe you end up with is exactly the same as if you had created it via new person. And then let's further examine function exemplars. And there you have two main entities. You have the constructor and you have its prototype. What do those entities do? The constructor is there for instantiation, and the prototype is there for everything else. So here are a few examples. If you make an instanceof check, internally what you actually do is, if you want to see is X an instance of C, what you actually do is you check whether C.prototype is in the prototype chain of X. So there, it's just the prototype that matters. Here again, if you subtype, if you create a subconstructor, if you extend an existing constructor, also what you mostly connect is the subprototype with the superprototype. If you do a supercall, obviously you need to refer to the super method via the prototype, so it's again the prototype. And if you use generic methods, it's the same principle. So what you have is prototype is used all the time, the constructor only once. But then you have to ask the question, what do we need the constructors for? Why wouldn't things be neater if we only worked with the prototypes? And then we wouldn't have this relatively complicated wiring. We'd only have a single very nice prototype chain. And this is what such an approach would look if you created and here everything is proper. Here you have Jane, whose name is Jane, and who has a title. And that instance is an instance of its prototype of the employee. And that prototype is a sub-prototype of person. And that object is, again, a prototype P of the library object that contains kind of the meta object protocol up there. So this is the library functionality, and and the neat thing is that that is inherited. These are extend and new methods that you should be able to invoke on a type, on an object exemplar. Extend says if I have an existing object exemplar such as person, I want to extend it. And new says I have an object exemplar such as, say, employee, and I want to create an instance from it or of it. So this kind of inheritance is neat because the whole library sits up here. So this is what it looks like in code. You see that person is created by extending Proto, and it's basically it is the prototype. And then it has a constructor that sets up the instance, it has a method, and then you create the employee by extending person. Again, prototype, there's some weird stuff down here that we're going to look at later. And so that's it. And I think that looks a lot nicer than the snippet we've seen at the beginning. And it's easier to picture in your head, too. It's easier to visualize. So this is how you use it. And when it comes to creating an instance, we're a tiny bit different. We just call employee.new, whereas with function exemplars, you would use the new operator. And if we want to check whether Jane is an instance of employee, what we do is we just check, is employee in the prototype chain of Jane? So really nice. And if you visualize this kind of the chain, then just to find out, is the object exemplar in the prototype chain, that works very nicely, I think. Afterwards, after you've created the instance, everything is the same. You have the same old instance. You can invoke methods on it, so there nothing much changes. How many lines of code do you think that is? Like, raise your hands. Above 50? More than 50 lines of code? Less? Raise your hands. Less. So the thing is, that's everything. So I've slightly cheated down here because I've used Proto here, which we're going to look at later. But it's basically already there. You don't need a lot of code. And this whole idea of prototype chains, that's like an incredibly elegant core of JavaScript. So let's look at ECMAScript 6 next. ECMAScript 6 will have classes, but those are classes by name only. And I really like the Brandon Ike video explaining the design of it. So what there actually are is syntactic sugar for a constructor, syntactic sugar for a function. So in ECMAScript 6, you're going to write class and some stuff behind it, after it. But what you get back is a function. So it's only syntactic sugar. But the benefits are quite impressive because you get ease of use, especially when it comes to subtyping. You get increased compatibility between frameworks, and at the moment, it's kind of a trend or a rule that if you have a framework, it usually comes with its own inheritance API, and that's a bit sad, but sometimes unavoidable. And thanks to the increased compatibility, tool support will be easier. Currently, you have to do a lot of tricks to get that, and classes will be the foundation for future extensions, and mix-ins are one example. So this is what it looks like. And curiously, it looks almost like object exemplars. Very nice, very clean syntax. And what tremendously helps us is that we have the super keyword down here. So this lengthy thing that we needed to call the super method, that is gone, and all we have is super down here. So that's very nice. So let's look at that. No, not yet. Let's look at how classes are translated. This should be fairly straightforward. You have a class person, and that is translated to a constructor function and a prototype. So far, not that impressive, but it gets better. Because here you exchange ugliness for beauty. And everything is fairly compact. And this is the scary snippet at the beginning. And things are really a lot easier to understand. All you do here, you clearly see that employee extends person. You have super. And it's just a lot neater. So now we look at super references, how those work internally. And you will have 4 ways of referencing super properties in ECMAScript 6. 2 are to reference properties, fairly obvious. Then you can call super methods, but you can also omit the name of the method, and then what's going to be filled in is the name of the current method. So that allows you to do, it's a more concise way of calling the super method. So this is how you currently do it if you want to make a super call. So super.method becomes this whole lengthy thing here. If you look at it more closely, there are actually 3 steps that are performed. Step 1 is superconstructor.prototype. This is where the search for the property starts. Next is method. That's the property we are looking for. And we look for it in this object and in all of its prototypes. Lastly, we invoke the method, but we keep the current this. And that's a bit counterintuitive initially. Maybe we'll see why it makes sense on the next slide. So one thing we would like to do, we would like to avoid hard coding in step 1, the superconstructor.prototype. We don't want to hard code somewhere inside of the code what the supertype is. And to do that, we introduce a special variable that's very similar to this. And this special variable, HomeObject, points to the home of the method. It points to the object where the current method is located in. And if you use HomeObject, you start your search obviously in the prototype of the HomeObject, not in the HomeObject itself. You look for method just as before, and you invoke it. So what you have here, this is internally, this is the semantics of a supercall. And then you have, here's an illustration just to look at it again. What goes on, if describe makes a supercall, you start your search in the prototype of the HomeObject. You look for the method describe, and when you call it, the this that this method gets has to be the same this, because this overridden method that gets called, it has to have access to the instance properties. So that is why this has to stay the same. You don't want to lose that object down here. You want to keep that. That's where the instance data is. And if a function up here accesses name or title, you want to make sure that the method up here finds it, and it has to find it via this. So these 2 values are crucial. Then there's one remaining question: where does the HomeObject come from? If I say that it's a local variable, how do we fill in that local variable? And in order to enable that, there will be 2 new internal properties that methods have. One will be HomeObject, and the other one will be method name, which allows you to omit the name of the method and to do this unqualified supercall. In ECMAScript 6, super is allowed only in classes, but in principle, nothing would prevent the scheme from working in any kind of a prototype chain, and it would work just perfectly with object exemplars. How are we time-wise? Okay, excellent. Next, another new goodie that ECMAScript 6 brings us is Proto. And if you look at how it's written, first you have to solve the problem of how am I going to pronounce that. You don't want to say underscore underscore proto underscore underscore. So the Python world has a lot of these double underscore variables, and they call it dunder proto. So that comes from double underscore. So that's a good way of pronouncing it. And Brendan Eich seems to like it, so it'll become popular for JavaScript. Dunder proto. What this special property allows you to do is you can get and set the prototype of an object. In ECMAScript 5, it's non-standard, and it's actually and ironically been discouraged for a while, but it will become part of ECMAScript 6. And, well, as I said, be a nice feature to have. It first appeared in Firefox quite a while ago, and it became so popular that there was pressure to add it elsewhere. We currently have support in Firefox and in V8. That means you can use it in Node.js, which is cool. And it's also available in Safari. So what are the use cases for Dunder Proto? Without Proto, you have to use this ECMAScript 5 function object get prototype of to access the prototype of an object. With Proto, it's a little bit nicer, but it's not that much of an improvement. Where you do get quite a lot of an improvement is if you want to create a new object that has a given prototype. So here we use object create an empty object whose prototype is my proto, and then fill it via assignment. And obviously, the alternative you have is to use object descriptors in the second argument. Who of you has used object descriptors already? Hands up. Okay. It's scary, so you're better off not knowing about them. No, I'm kidding, but it's not pretty. It's a lot of noise. So it's really, sometimes you need property descriptors, but with Dunder Proto, you'll have a very nice alternative that works for the most use cases. With Proto, you get to use object literals, which is always good, and everything becomes more compact. Then there's one more use case. If you want, built-ins in JavaScript are notoriously difficult to subtype. So the problem with array, for example, is that array instances are special. So if you want to subtype array, then you can't, or at least, no, you can't. You can't create those special instances. So what you do is, and what you can do thanks to Proto, is you just, initially you create an array, and then you swap the prototype of this instance with your own prototype. And that's how you create, how you turn the initial array, the special instance, into an instance of your own prototype. And then you return it. That's a tiny hack that's, I think, is used by Zepto for. So this is the interaction, and you notice that if you add an element, length is automatically increased. That is not something that you can do by hand. You can check whether Dunder Proto is supported, and you do that by creating an object that uses Dunder Proto, and then check, has the prototype actually been changed? And if not, you know that Dunder Proto is not supported. There's one caveat with Dunder Proto. You have to be even more careful when it comes to what keys you allow. So if you allow arbitrary keys, then you have to be careful, because you can really wreak havoc if you use Dunder Proto here. And there has been a bug in Google Docs for a while ago, where if the first word in a Google Doc, if you type that word and if it was Dunder Proto, then Google Docs would crash. So they can invent your own reason why that happened internally, but they probably stored something in an object. So typing Dunder Proto crashed Google Docs for a while, until they fixed it. Dunder Proto will be in ECMAScript 6. You'll be able to use it as a getter. You'll be able to use it as a nicer object create. You might be able to use it as a setter, but it might be enough to just make subtyping built-ins easier. That's another possibility, because other than that, there's not a lot of use cases for making Dunder Proto mutable. You will be able to switch it off, at the very least for some objects, possibly for all objects. That's not yet been decided. Conclusion. There are a few takeaways. The core of JavaScript inheritance is simple and elegant. It's just objects and the has prototype relationship. I think object exemplars underline that simplicity and that elegance. So they are instructive. They teach you something about about how JavaScript inheritance works, but they're not really for the mainstream because you want to be compatible with other code. But you still can have nicer ways for implementing types because, or in the future, because in ECMAScript 6, you get classes, you get super, and you get dunder proto. So those will help. Thank you.
Awesome. Wow, lots of questions. Let's do it.
What is the reason for keeping dunder proto separate from the normal prototype? I mean, the idea is close to reuse the existing prototype property instead of dunder proto. Why is it important to keep it separate?
Those are different things. I mean, once you have the prototype object that's inside, that points to the prototypical object for the instances, and if you have with dunder proto, you have the link between objects in prototype chains. So those are completely different. There's an unfortunate overload of names in JavaScript. You have the prototype relationship between two objects on one hand, and then you have the prototype property of a constructor function. And that is something completely different, even though that object eventually becomes the prototype of the instances. But that naming overloading is just, it's terrible. But those are completely different things.
All right.
Sorry, I really like the ES6 classes and having a constructor key that's the equivalent of the old constructor function. Is there a shim for ES5, and where can I get it?
Is there can you repeat that last?
A shim, something that'll backport that and run in an ES5 environment.
The problem with new syntax is you can't really backport it. There are a few lightweight libraries out there that look almost the same. And they're really just syntactic sugar so you don't get really a new feature, it's just nicer syntax.
I was just hoping for some future compatibility.
And there are, I forgot, and there are a few, have you heard of Trasur? It's a Google project that on the fly, it compiles what you have. So you can use ECMAScript 6 syntax, and it compiles it on the fly to ECMAScript 3, I think. And obviously, you have TypeScript that is largely based on ECMAScript 6, especially when it comes to classes, and then additionally has type annotations.
Great, thank you.
So there are a few solutions out there.
Anyone else? Going once? OK, cool. Thank you very much.
Thank you.